Enterprises require advanced AI inference to process proprietary data, but strict security mandates forbid internet connectivity for sensitive internal systems. Connecting to a cloud-based API is a compliance violation. To resolve this, we use the NVIDIA Inference Microservice, or NIM, isolation protocol. This is a standardized 11-step method designed to achieve a fully air-gapped deployment. Before initiating the protocol, you must establish the prerequisite infrastructure. This requires an internet-connected staging machine, a compliant cross-network transfer mechanism, internal registries, and pre-configured security endpoints. Executing these 11 steps sequentially guarantees the final inference service is functional and fully insulated from external access. Step 1 begins on the internet-connected staging machine. Here, we execute the pull commands to acquire the latest NIM container image. Step 2 targets the data payload. We download the specific AI law weights and package them into a standardized, self-contained directory called the model store. Looking at this directory structure, Step 3 requires us to generate an SPM and execute vulnerability scans. Once files pass, the payload is visually stamped. We record this cryptographic hash to confirm file integrity before unpacking. By completing these first 3 steps, the payload is rendered entirely self-sufficient and cryptographically verified. All of this occurs before the assets ever approach the secure perimeter. Step 4 is the transfer. We move the verified assets across the air gap using a compliant mechanism like a data diode. Once the assets are securely inside the isolated network, Step 5 is pushing the transferred NIM image into the internal Harbor container registry. For Step 6, we unpack the transferred model store files and position them directly into a designated local storage path on the internal inference server. Positioning these assets internally perfectly mimics a cloud-based registry environment, tricking the service into operating normally without an active internet connection. Localizing these specific assets is mandatory. It severs all dependencies on external package managers during the runtime phase. Step 7 mandates modifying the container definition by deleting the external API key entirely. If it remains, the container attempts external validation and times out, crashing the deployment. Removing it keeps the process contained. Step 8 points the system to our verified assets. We configure the environment variable, specifically NIM model path, to map the container to the local model store path. Step 9 is executing the final startup command to boot the AI inference service using exclusively the local pre-verified components. By stripping out external credentials and strictly enforcing local paths, the system is forced into a purely localized, self-reliant initialization sequence. With the service active, Step 10 is to route all internal traffic directed at the new NIM service through a centralized API gateway. At this gateway threshold, we implement strict role-based access control to block unauthorized users and enforce rate limits to ensure incoming traffic exceeding a specific volume is dropped, preventing internal abuse. Step 11 configures advanced log routing to capture the exact content of all user prompts and the resulting AI outputs. These captured interaction logs, combined with access timestamps, are automatically ingested into the Enterprise Security Information and Event Management System, or SIEM. Raw inference capability on an internal network introduces a security liability. Inference wrapped in gateway controls and monitored by a SIEM becomes a fully compliant enterprise asset. The deployment is now complete. An authorized internal user submits a prompt and receives an immediate AI response entirely within the air-gapped environment. Looking at this dual-pane interface, we observe the execution on the left, and simultaneously on the right, an immutable audit trail is automatically generated in the SIEM dashboard, capturing the prompt, timestamp, and user ID. Adhering strictly to the 11-step protocol isolates a complex AI microservice. This transforms the NIM into a localized, fully audited operational tool that operates entirely within the secure perimeter.